Hi and welcome. This time around I have an exciting new tool to add to the workshop. It's one I've been lusting after ever since I saw Adam Booth receive his, except his was an American-made hydraulic one. I think it probably cost maybe 5-6 times what this one cost. This is an electric tapping machine, and unlike Adam's, it's not hydraulically run. So Adam's has a hydraulic pump that moves the motor for the hydraulic motor on the head to control it. This is an electric one, servo driven, and it's made in China, so it's a lot less expensive than its American equivalent. I think the American equivalent start at like $2,500 to $3,000 and go up from there. So I'm really excited about this. You guys have watched me do a bunch of projects for fixturing. Well, I set aside a good chunk of money from those projects and left it for this. I've been trying to get one for a long time because I really hate hand tapping, and this will speed things up immensely. Hopefully it works well. If it doesn't, well, you can learn from my experience, and if it does, hopefully then you can learn from my experience. Even though this was pretty well packaged, it did get mauled on the other side a bit. Some of the wood got damaged. That's not a huge deal because I think the contents will still be okay. It's got strapping, and then it's got these interesting little clips that hold the top down, going all the way around. I've never seen a design quite like this, top and bottom. So let me get those open and we'll move on to the next step. We've cut the straps and bent the tabs up. Now we're going to see if this top comes off. Seems like it's a little bit loose. I'm going to need both hands for this, so bring it right back. Well, a nice cross brace here. That's a good idea. That's probably why this thing is reasonably stable. And then they had to go and fill it full of ghost turds. That's just plain mean, right? These things are statically charged and will stick to absolutely everything. I don't know. That's a mean sense of humor that packs things with that stuff. All right, I got enough ghost turds out of the way. We can get the tool out of here. So we'll take the tool out and then put the rest back, all the ghost turds back in, and seal this thing back up again forever. In the bottom, a bunch of packets of chiclets. That's exciting. We'll throw that in one of my toolkits, help keep them dry. All the sensitive bits were wrapped in saran wrap to keep the moisture out, in addition to the chiclets, including this solid post here, which is a flange welded to a pipe. Well, solid steel chunk, actually, not pipe. That's a heavy-duty vertical mount. I'm thinking this is going to end up over here, even though that means lubricant's going to be used here, and having oil anywhere near where you're welding is not a great idea. It means I'll have to put something down the surface when I'm tapping over here. But it's only the place I have that's large enough where I think I could do this. So they took even extra care to protect the servo motor head assembly down here with additional packing. I hope that the quality of this thing matches the attention they paid to shipping, to packing it. This is the handle to control in and out. They left it loose. I hope they did that on purpose. It's missing a screw, but they might have left it loose so it didn't get damaged in shipping. That's entirely possible. That can give. So we'll get this guy apart a little further and check it out. Here's the unit held together still by a very heavy-duty tie wrap. They had additional protection over the head itself, over the business end that holds the collets. So I'm afraid to release this until I have a place to mount it. I'm thinking about putting this guy and just mounting it back here, because I can just push it out of the way when I'm welding, and I can get a mat to cover this while I'm tapping. I know, multi-use, not ideal. All right, so here's everything out. This handle goes mounted somewhere. I haven't quite figured that out yet. This is the universal head, so it allows it to rotate at multiple angles. You can buy it in a version with a fixed head where it only does perpendicular, and you can also buy it in both the universal and perpendicular with added air or coolant distribution to your tap head. I didn't want that because that would just make a mess. I have nowhere to control that. Here are your tap holders. And they have torsion control in each one so that you don't break the tap. It's adjustable. And it came with a drill chuck and an arbor that matches the 3/4 mount of the rest of these guys. It came also with some tapping fluid. Anti-wear steel tapping oil. That's interesting. Again, I don't know where that handle goes, but I'll figure that out. And I noticed this is kind of odd. It's got a 110 volt connection here, a standard one. This thing said it was 220 everywhere. I figured I was going to have to feed it with 220. It does draw a kilowatt max, which is not excessive. I mean, people have 1500 watt blow dryers, so it should work on 110 fine. Let's see if that really is 110, because it's got a 110 outlet on it. And it's got the nicest looking manual I've ever seen, color. Have you ever seen a Chinese manual that is so nice? They really went the extra mile on this one. I'm very impressed. Look, the power supply is single phase 220. It says right there. That's really interesting. Why a 110 plug then? I'm still not quite sure about that. We'll get further into that. All right, so we've got the unit installed now, and the post is now drilled and tapped into the 1-inch aluminum plate on my table saw. And it's kind of amusing and sort of ironic that I had to hand tap the mounting holes for the tapping machine. It's also ironic that the handle with the controls on it for the tapping machine has a hole with threads that are stripped. So the tapping machine that makes good threads has bad threads on one of its holes. That's sort of ironic, I think. I also replaced the connector on the AC cord with the 220 connector, and I've just decided, in spite of the fact that was a 110 connector that came with it, I'm looking here, it says 220 volts there. On top of the servo motor, it says 220 volts. So I'm just going to trust that this is 220 volts. Now again, this is a universal head, so this adjustment does pitch, and this adjustment allows yaw on the head. You can buy it in a fixed mode, where a model that's slightly cheaper that's just fixed at 90 degrees. I could see where that would be useful. I wanted the possibility of more options, and it's not much more, so it seems like it's worth it. The holder that comes with it, interestingly, supports 6 of the tapping holders, but the unit comes with 8, which is nice. I think that these 2 were sort of an extra afterthought, and they just decided to include them, which I'm not complaining about, because you need one for every unique size of tap. So this won't hold all the taps at all. Nor will it hold the drill chuck, which comes with its arbor. There's a power switch on the back here, which I think is kind of odd, and it's good that that bulb didn't blow out. Probably a neon. I guess that means it is 220. And this came up, so I guess that's also 220. So it's set for manual mode, and you can choose your tap size here, British, and then you can go ahead and choose your tap size. They go quite large with some, wow, 4-inch. I don't think this thing will be able to tap 4-inch very easily, but that's kind of neat anyways. Touchscreen is okay to use. Oh, there you go. Touchscreen's just a little unresponsive, so let's go to 300 and 300. I think that might be max for this unit. Tapping depth 7.5 millimeters. So even though it's set for English units, the depths are still in millimeters. So 7.5 millimeters is not very deep. That's less than a centimeter, and it's 2.54 centimeters to the inch. So let's say we're going to go in 1 centimeter. Is that in millimeters? It was 10 millimeters. Torque limit 2 nanometers. And then you go back. And it shows how much torque is on it at the moment, which is interesting, because that's just free running torque. All right, so I was looking at the parameters, and I went to some of the more advanced parameters. I thought, oh, let's see what restore to factory parameters will do for you. Well, it does restore to factory reset after you enter the password, which by default is 316. And when you do that, it'll be in Chinese. And if you just turn it off and turn it on, it's going to stay in Chinese, and you can't see where to put it back to English. What you have to do is you have to leave it off for a while, and then it'll ask you what language, and you can choose English again. Now, something I thought was kind of unusual here is it sets depth, right? That's 7.5 millimeters depth for this particular tap. And if you have it in normal tapping mode, then it'll just tap all the way to 7.5 and come back. And if I just let that go here, You can see the depth going to 7.5 millimeters, and it's backing out. And it does a count, how many you've done. If you change this to vibration tapping, it goes in a few laps, goes 3 millimeters, comes back 2, goes in another 3 millimeters forward, back 2, 3 millimeters forward, back 2, until it reaches its final depth, and then it backs all the way out, which is nice if you're doing a deep hole. Here's the problem I see, which is a little problematic, is that nowhere can you set this pitch value. I assume that's 1.058 threads per millimeter. Well, let's say this 3/16 tap was a 632, and I wanted to go to an 832 or a 1024. My point being is that I don't think all of those taps, well, the difference between fine and coarse threads is a different pitch, and that depth will depend on that pitch. So you might have to compensate with a funny number in order to get your depth right, and the depth is in millimeters rather than threads per inch, so you're gonna have to do that translation as well. So it's unfortunate that when you go to British units, not everything goes to British units, number one. Number two, there's nowhere I can see to enter that pitch value here. And I'm going to call the manufacturer and see, well, I'm going to call the vendor, the distributor here in the United States, and see if they can explain why there isn't any adjustment for pitch size, because that's actually important. So let's see if any of these taps will match up with anything I have. Oh, by the way, there's a torque setting. So when you're in manual mode, in the British system, let's just go back to 3/16, you can set the torque limit. That's 4.8 Newton meters. Well, if this torque is off, it'll just keep torquing up till it potentially breaks the tap, except that the tap holders themselves can slip. And that adjustment is set by tightening this ring here, which comes with a spanner. So you can actually set a torque breaking setting on it. And it looks like they have it set to 7.26 nanometers for that one. Newton meters, sorry, not nanometers, Newton meters. This one's 3.86. So I think they're preset the factory, but you can make adjustments as necessary. So even if that torque is off, but if the torque is on, the servo motor senses the amount of torque and it will automatically stop, which is kind of nice actually. I was gonna fix this thing and I noticed there's no threads in the front here, and I can see on my screw that was sitting in the bottom of the box, there's my threads. They just got pulled right out. So maybe this thing got damaged during transport. Except you would think that would be this way, not pulling up, because the box would have banged it this way. I'm still not sure how this happened, but there's my threads. So I'm going to try and tap this up to a larger hole, maybe drill that out to the next hole size, and see if we can get this handle to be tight, because when it's not tight, it's a little unfortunate. Drilled this out, and I'm tapping to M6. I happen to have screws in metric. I've purchased some just so that I have a stock, because more and more stuff comes metric, which makes sense. So we're going to try and repair this. And we're all better. Handle fixed. I should have drilled out both, but rather than just risk damaging, I probably could remake this part here too, although I don't know what it's like inside. But you've got servo motor on top, reduction gears here, and or maybe here, I'm not sure which, and then this mounting plate that connects them together and allows mounting to the main arm. This might be easy to remake, but rather than risk it, I'm just going with it. I went with a larger tap size, didn't have to drill out the handle, it actually fit. I could increase that one as well, but for now I'm just going to leave it so that it's closer to factory, but we're good. Alrighty, so solve the pitch problem. I think I've figured it out. The manual, beautiful, color, glossy sheets, content, not so much. These tap sizes here I thought corresponded to the holders, but in fact this actually relates to the pitch, which I'm not quite sure how they figured those fractions out relative to the pitch, but it kind of works. So here's what I did. If you enter here, if I go to British system and for example I choose 1/8, the pitch is 0.635. So I created this Excel spreadsheet here, which basically takes that pitch in millimeters, divides by 25.4, and divides that whole thing into 1. So what you end up for 1/16, for example, is 60 TPI, 1/8, 40 TPI, which is what we were set to. So we can do 440, 632, 1024, 1032. They duplicate some, which makes no sense to me, especially at the bottom part. They duplicate the pitch on each one, on every pair of sizes, as if 3 3/4 was 3 threads per inch, and so is 4. By the way, if you want to look at the actual number, they don't usually work out to even numbers. For example, I just rounded up to the nearest whole number. 3 1/4 is actually 3.25 threads per inch. 3 3/4 is 3 threads per inch. 60 was 60.047, 48, 48.015, etc. Looks like 40 hit right on. So they're very close, but not dead on. Now, all that controls is how deep this tapper is going to go before it stops, because the pitch is meaningless otherwise. I think it counts number of revolutions to calculate depth. Other than that, not important. It may also set, so let's just take a look here. So some of these duplicate ones, let's see if there's a difference there. So why don't we choose, let's see, the first duplicate was way up here, 24 threads per inch, 3/16 and 7/32. So the thing I might be different, 3/16, if I go in here, the torque limit is 4.8. If I go back and I go up to 7/32, the torque limit goes up. So that's the only parameter that changes. If you're not using torque in this guy, but rather using the torque setting on these guys, you're good to go. Next job, here are the tap heads it came with. And this is the tap size that it fits, including the outer diameter of the tap and across the flats of the tap. I got to figure out which taps these equate to, so I'm going to do that next, because this is not particularly useful. They don't tell you this is for a standard 440 tap or a standard 632 tap. No, that's just a size dimension, and maybe they vary. Maybe they're not standard, but I got to tell you, it's a little disconcerting. So this next bit made more sense. This fraction is literally the tap that'll fit. So quarter will fit a quarter 20, quarter 24, quarter 28 taps. The tap diameter is 0.25 by 0.19, and that is exactly true. Same for all the ones above, up to 5/8. 3/16 is number 10, so that tells you the smallest this will do with the tapping collets it came with is down to number 10. If I want to do smaller, I'm going to have to buy other ones. And this machine goes down to 1/8, so I don't really know how I'm going to actually what size that actually goes down to, but I'm looking into that next, because I'd like to be able to do number 8, number 6, maybe even number 4. I don't know, maybe this machine's too strong and they're just worried it's going to break, but we're going to look into it anyways. So, oh look, it's got a built-in advertisement as a screensaver telling you the upgrades of this thing. Double tap protection, more convenient operation. So it's got a screensaver that's an advertisement. That's brilliant. So you've got manual and auto mode. In auto mode, it goes and taps to the depth that you set. In manual mode, it'll just keep going. That's removal. This one goes to the depth you set. By the way, there's no abort. So you just got to let it finish if you're in this mode. So let's take this depth back down smaller for this for 5. If I have torque off, then that torque limit you set, it completely ignores it. So that's not really relevant. This is set for vibration. Here's normal tapping. If you go to manual, it tells you how deep you are, and you can edge it in yourself. That's pretty handy, and then you can walk it right back out. That's a really nice feature. Some of the things they did extremely well on this device, some things not so much, like having to translate, having to have a table to translate. That's not so hard. They could have done this, and more importantly, they could have done this in software. And the depth, when you go to British units, the depth could have switched from millimeters to threads per inch. That would have been pretty handy, or inches, I guess, in this case. Would have been pretty handy, but in any case, they didn't, but it seems like it's working fine. I think next up, we just try this guy. So I picked a tap size I'm going to do quarter 20 first, which is just the 1/4 inch chuck, which I have right here. Nicely labeled on the side, quarter 20. Says it should be 4.85, I'm guessing Newton meters. You slide this bit up here, rotate till you find the detent, and you're in. To put the tap in, there's a little bit on the bottom here. Here's another one. And this part is kind of stiff on the new ones. You hit them down once and then they go. So this part here is the tap release, and it just holds the tap fairly gently. At first I couldn't figure out how to get the taps in. I go, oh man, these things aren't the right size. But they hold very nicely actually. So this is a quarter 20, so we need 20 threads per inch, and 20 threads per inch would be the 1/4. I guess they're considering coarse threads normally, so we'll choose quarter. And just for the heck of it, I'm kind of curious here. I chose quarter up here, British system quarter, just in case you missed that. So the pitch should be right. If I go in, the torque limit is actually set high. I'm not going to use the torque limit to set this guy here. I am going to rely on the torque set on this guy, figuring it's closer, maybe, I don't know. I don't know how accurate the servo is with torque settings. The depth is currently 7.5 millimeters. We're gonna try a variety of torques here. So I made up a plate here with lots of holes in it, varying depths. Some of these other holes were already in the plate. This was scrap material. There's 1-inch thick aluminum cast aluminum plate. Actually, no, this one's extruded. This is not cast aluminum plate. This is extruded plate. These 1/4-inch holes are ready for a 1/4-inch tap number 7 drill bit. Go all the way through. These are 1/4-inch deep. These are 1/2 inch deep. That one has a little bit of debris in it. Got to get that out before we tap it. There we are. And these are 1/2 inch, prep for 1/2 inch tapped holes, 70% threads in aluminum. So first, I guess we'll just try a manual tap in the first hole, see how it goes. What I probably should have here is a vise to hold this, because I'm going to be having my hand on the tap machine. I suppose I could hold the work, but then it's hard to hold the camera as well. We're going to try full manual first. I've tapped the upper right-hand corner, which switches between auto and manual. We're going to do normal tapping rather than, go forward a couple threads and come back a couple threads, because we're not going to go that deep at first. And let's see what we can do. Hopefully we won't break a tap. All right, so I've cut this down to fit inside my vise that I can fit over here. The first one I'm going to do with manual, and we're going to use some anchor lube on the tap. And we're just going to do it manually. Let's see how hard this is. Okay, so you really need to hold your vise, have the vise down. That worked out pretty well, except for the fact that I wasn't holding the vise adequately, so we'll need to fix that. Maybe I can get a clamp over here and clamp the vise down. Alrighty, so we got this thing clamped in. Let's try a second one, and let's try putting it in vibration tapping mode. You can control how many threads forward and how many threads back before it reverses. Let's see if we can go all the way through this guy instead of just a short way in. So, oh, I guess it only works in auto, so I could back off manually. That worked like a charm. That went through it like butter. No issue at all. Now this is supposed to be capable of up to 5/8 inch. Wow, that was really impressive. And those are nice looking threads too. I am very impressed. That was much better quality than I expected. I mean, I guess that has a lot to do with the tap, but how rigid the holder is also plays an effect. So next up, we're going to try automatic. And I'm going to choose my depth at 6 millimeters, which should be roughly a 1/4 inch. It does accept decimal points, and there is a torque limit preset for this, but we're not using it. All right, so let's see if this, and it's set for stutter mode too, if I remember right. It is. We'll try regular mode first. We're going to just go in a 1/4 inch. So it counts when it starts, so I didn't push all the way down. That was my bad. Okay, that looks like a 1/4. That did a good job. So let's try double that. Let's try 12. So that would be about a 1/2 inch. 12 millimeters is what I've chosen. And we'll do vibration tapping, which is their mode where they back up. So here we go. By the way, you can choose how many revolutions forward and how many revolutions backwards. And that looked like it nailed it. Very nice. That was very impressive. All right, so this is a 1/2 inch deep hole. Let's try on the last one that's a through hole. Let's set it for regular tapping, no backup, and we're just going to go in a 1/2 inch. Now remember, when you start on this, it needs to be touching the material because it's counting revolutions from when it first starts. So we're trying to go a 1/2 inch complete in one go and easily handled it. Next up, got a 1/4 inch deep hole here. I'm going to set the depth to 5.5 millimeters. Now, if it's wrong, and the reason I said 5.5 is because I set my drill press to drill 6 millimeters or a quarter of an inch. But the problem with that is that I chose that at the conical point end, so it's actually going to run out of full diameter before a 1/4 inch. Let's see what happens. This might be catastrophic. Let me get you down lower. All right, so here we go, 1/4 inch. Oop, well, I guess that did not have the depth set right, and the tension on this thing was not right because it snapped my tap right off. Now, maybe they've got the torque setting and this thing based on a regular tap. This is a spiral flute tap, which is very expensive, and this is an E-Mooge, so I'm kind of bummed about that. I guess I gotta get another tap. Be right back. Well, I discovered what went wrong there. So in the menu, let's see if I can pop you up here to see this. In the menu, if you're setting the tapping depth, when you go to that menu here, if you don't hit the back button, it doesn't actually set the value. So it was still set to 1/2 inch deep. So I'm going to be extra careful, and I've got it to 4.5 millimeters, but we should be good here. And we're going to try the 1/4 inch deep hole here. Hopefully we won't break another tap. That was expensive. Perfect. Very nice. And those threads go all the way to the bottom. That's very good. So have a couple 1/2 inch, oh no, one more 1/4 inch hole. Let me up that to 5.5. Well, I should be able to do 6, right? Let's do 6. First, I'm going to test it. It indeed goes and stops at 6. I guess it was never its fault. It's just a weird user interface when you hit the button, you hit OK, but if you don't hit the back button, it doesn't actually take. I call that a bug in their software. All right. Let's try another 1/4 inch deep hole here. And nailed it. Very good. Do one more and I'll let you see the menu, the screen while it's working. It's hard to do things with the camera in the way. Okay, so I'm holding this at the hole right now and I'm hitting start. And we're there, another very good hole. Okay, this is running purely manual mode. And that was no problem at all. That was less effort than when I had it on automatic mode. That went very painlessly. Beautiful threads again. Last hole, we're going to go in full auto, all 27, and we're going to leave it back on vibration mode, except we're going to modify the vibration mode again, and we're going to have it go forward 5, back 3, just to experiment. Hopefully we won't break the tap. All right, here we go. Got to get it lined up. Should be using 2 hands. The camera's right in my way. And that was it. Flawlessly. Very impressive. Here's the final results in tapping. There's my half-inch deep threads all the way through, all the way through. You've got a couple where we went in just a little bit, 1/4 inch. And I think that might have been just, yeah, that one's a little shy of 1/4 inch. That one's closer. I purposely was being careful after I broke the first tap. That one I think went 1/4 inch. This one's 1/2 inch, just shy, and this 1/2 inch all the way. You can see in there, hopefully see the threads all the way through on one here. That one's nice. Yeah, just all the way through on that one. Turned out pretty darn good. I'm pretty generally impressed with this. All right, so here's the unit. Overall, I think the unit's okay. It definitely has its caveats. The poor translated English menu structure, not so great. The giving pitch in millimeters is utterly worthless for your American audience, because we do TPI unless you're gonna do metric, in which case it's just fine, which this thing does as well, just fine. So this has the ability to do English and metric. I'm not quite sure what the custom, I think that just lets you set the torque setting, that's about it. I couldn't tell, there's no pitch control on that and the only thing, let me go back, the only thing you need pitch size for is to control the depth, because you need to know the thread pitch in order to know how deep you're going. So that has to be right. I've made a spreadsheet that calculates those values for you. I'll make that available to anyone who wants one. I don't know how many people are going to want to spend this much money, just skip tapping. I make tooling plates, things like that, with a lot of tapped holes more often than I care to. And I just got tired of tapping, and using a drill motor to do it definitely doesn't work well. You've got way too much likelihood of going at an angle and snapping the tap. Ask me how I know. Sometimes you can do it on the mill, but that's not always convenient. Sometimes it's good, easier to drill all your holes and come back and tap them rather than go back and forth, because on the mill, you could get some of these slip collets for the mill. That may be another solution at some point. I did find that these were set too tight on the 1/4-20 because it broke. It shouldn't have. You take this little spanner supposedly and adjust this tension here, and that'll adjust how much torque is on this guy. First you have to take this ring off the outside because that locks it. These are detents where that little pin goes into. So I didn't make those changes. This should be definitely set lighter because it's just snapped right off. That was one of the weakest taps that you could actually have. That was a spiral flute tap, and they're really thin. The core of that tap is very small compared to other tap sizes. So that was a good test for that. The bender, not terribly responsive. I called a bunch of times for tech support, was on hold immediately. You know, I hit the tech support option and it went straight to hold music. I tried 45 minutes the first time, then a half hour. 45 minutes was at 6 a.m. in the morning when or I did it at 6:30. They're supposed to be 6 a to 6 p Pacific. That did not help. They never answered. Eventually I gave up, and yesterday I called sales and they picked up immediately, and they said, oh no, we can transfer, there's someone from support available right now. And they transferred me right over, and someone was very helpful. Their first thought was to send the whole unit back. I thought for a stripped screw, $70-something shipping for a 60-pound box, 65-pound box, total waste of money on everyone's side. I could always retap it. They said, oh, well, we'll give you some money back. I said, fine, that's not terribly necessary. I'm just reporting there's a problem, mostly. I thought maybe they could send me this part that was tapped and you know, not damaged, and I asked that option. They checked and they don't have that part available, not surprising. They're only like 100 miles away from me. I could drive there and swap the unit out, except they don't have any more of this unit. I don't think it's worth it. I just drilled and tapped this to the next size larger metric screw, and we're good to go. So and I could probably remake this piece. I don't know what's in there, but it looks like a pretty simple piece, so I could probably just remake that piece as well. The company is fairly inexpensive. Actually, they're cheaper than some of the Chinese sources, which is really weird. Not cheaper than all of them, of course, but you don't have to wait a month for shipping. And the shipping was it free? I can't remember. Maybe shipping was paid. I can't remember at this point, but it was reasonable. I had to pay sales tax because it's inside the United States. I guess overall, the unit's worth it for me. Definitely weigh your options. The American version probably be better in every regard. Certainly the menu system wouldn't be a problem, and they'd have American size everything if you need it. This does metric as well. You got to buy different ones of these for metric. There are options out there. Tool Lots does sell more of those, so I'm going to look into the smaller sizes. That really freaks me out, though. You might just snap the taps off. This thing has an amazing amount of torque. So I found the lower torque settings, and the way I tested that was I grabbed this guy when it was running, and at like 5 or 6 Newton meters, it would just immediately time out, because just starting it up, the initial start torque to get all of the planetary gears moving, whether they're here or here, maybe they're here. So getting all the planetary gears moving was enough torque to cause it to torque out. So for smaller taps, it may be problematic. You may have to have a light touch yourself. So just to think about. Anyways, I'm happy with it. Could be better, but perfectly adequate. A lot of money, but a lot less than one that I think would be a lot better. So I knew that risk when I bought it. Anyways, thanks for watching. Hope you find this a little bit useful, and hope to see you next time.